Hello guys, welcome back to a new video. In this video we're going to talk about fluids pressure and temperature. Now I'm going to explain pressure and then we'll talk about Pascal's principle. Then we will solve practice 3B. And look, we have pressure. So imagine you have an object. Okay, let's say you have an object. You're applying a force on this object. Okay, it's called, let's say, F. Okay, now this object has a unit area too. It has area. Okay, so the force applied over a unit area is called what is called pressure. Okay, so pressure is equal to F divided by area. Okay, now as you know, force is measured in Newton and area is measured in what? In meter squared. Okay, this is called what, guys? Remember, this is called Pascal. Okay, this is for finding the pressure on an object. Now guys, look, as you know, these two are what? Are always directly proportional. If force increases, so let's write this one here, are directly proportional. If the force on an object increases, then the pressure is going to increase too. These two are what? These two are inversely proportional. These two are inversely or indirectly proportional. Okay, let's just write indirectly proportional. Okay. If area increases, pressure is going to decrease. If area decreases, then pressure is going to increase. You have something else, guys. Just know that atmospheric pressure, one atmospheric pressure, which is the pressure of the atmosphere, okay, this is equal to 10 to the power of 5 Pascal, okay? So if you have 5 times 10 to the power of 5 Pascal, then this is basically how much? This is basically 5 atmospheric, okay? Or you can just simply write it like this, 5 atm, okay? So this is for the atmospheric pressure, or the pressure of the atmosphere. Regarding the equation, remember that we said F and pressure, or force and pressure, are directly proportional. So if you apply this to a pencil, the edge or the head that is not very sharp, it has a larger area. So if you press or if you apply force on it, it's not going to hurt too much. But you see that this tip is sharp and it has what? It has a small area, so the pressure there will be much higher, so your hand is going to hurt much more there. Or if you have a knife, okay, if you have a knife, okay, the edge is going to what, guys? The sharp edge, okay, the sharp edge here, this one, it has a smaller area, okay, this one, it has a smaller area. That's why if you use this to cut fruits, okay, it's going to cut much easier than this sharp, okay, than this one, this edge here. Why? Because it has a larger area, and if it has a larger area, then pressure is going to be lower. But here, area is smaller, so the pressure will be higher. Okay. We have before that. Pressure depends on two things. It depends on the force applied and it depends on the area. We have applied pressure in a fluid, okay? If you apply pressure on a fluid, imagine that you have a balloon, it has water in it, it's filled with water. If you apply pressure on this balloon, you're going to see that the pressure is distributed equally throughout the balloon. We have something called a hydraulic fluid, something like this, okay, which is used to lift cars. The small piston here, guys, it's called small piston. The area there, we call it A1, and the force applied, okay, when you apply force here, we call this one F1. And the place where we put the car, we call this one, its area is called A2. And the force that comes here from the fluid, which is in the up direction, this is called what? This is called F2, okay? So in the question, sometimes it's going to say small piston, or sometimes it's going to say a liquid is pressed. So if it says pressed, then you know that it's coming from this direction. Or sometimes in the question says a car is placed on a hydraulic fluid, so you know where is it put. You know that it's F2 or A2. You'll be solving questions and it will be much clearer when we solve it. So this is Pascal's principle. It says pressure applied to a fluid in a closed container is transmitted equally to every point of the fluid. Okay, we have sample 3A. The small piston of a hydraulic lift. Okay, the small piston of a hydraulic lift. Do you remember, guys? We said the small piston, it has what? So area 1, okay, is equal to 0.2 meter squared, okay? It says what? It says the small piston. It's clear. A car weighing, whenever it says a car weighing, you remember, so it's put here, it's put to this side, okay? So this is what? This is F2, okay? And it has the unit of Newton, so you know it's force, okay? A car weighing 1.2 times 10 to the power of 4 Newton sits on a rack mounted on the large piston. The large piston, so you know it is the large piston. The large piston is this one, by the way. This is the large piston, and this is the small piston. The large piston, so you know this is what? Area 2. It has an area of 0.9 meter cubed. How large a force must be applied to the small piston? So it needs what, guys? You have A1, you have F2, and you have A2, okay? So it needs what? It needs F1, okay? F1 is equal to what? And by the way, I forgot to talk about the equation. To calculate or to use Pascal's principle on a hydraulic lift, we will say F1 divided by A1, okay, and F2 divided by A2. So this F1 here divided by this one, and this F2 here divided by this one, A2, okay? So we are going to say what? We're going to say F1 divided by A1, and you have what? You have F2 divided by A2, okay? Now look, guys, you have area 1 here, you have F2 here, and you have area 2 here. You don't have this one, okay? So we are trying to this one. Rearrange the equation. We will say cross multiplication, this one multiplied by this one, and this one multiplied by this one. So you will get what? You will get F1 multiplied by area 2 is equal to A1 multiplied by F2. You needed to find what, guys? You needed to find this one. So divide this one by A2 and this one by A2 too. So this one goes with this one. F1 is equal to what? F1 is equal to A1 multiplied by F2 divided by A2. A1 was equal to what, guys? It was equal to 0.2 times F2 was equal to what? F2 is equal to 1.2 times 10 to the power of 4. Then you had A2, which was equal to 0.9. Then calculate this, you'll get 2.7 times 10 to the power of 4 Newton. This is the force that must be applied on the small piston. Now guys, we have practice 3B question when it says, in a car lift, compressed air exerts a force of 1.33 times 10 to the power of 4. Now guys, look, it says the compressed air, okay? It doesn't talk about the small piston. It's talking about the compressed air or the compressed fluid here. So this is what, guys? This is F2, okay? F2 is equal to 1.44 times 10 to the power of 2 Newton, okay? Then on a piston with a radius of 5 times 10 to the power minus 2, this pressure is transmitted to a second piston. So let's talk about the second piston. So you already know this one is R1 and this one is R2, okay? you can take this note that R1 or area 1 is always smaller than area 2, okay? Now R1 is equal to 5 times 10 to the power of minus 2 meter, and R2 is equal to 15 times 10 to the power of minus 2 meter. This is what? This is radius. It says how large a force must be compressed, must the compressed air exert to lift a car, okay? So it needs what? It needs F1. F1 is equal to what? Okay, as you remember from the previous question, we said F1 divided by A1 is equal to F2 divided by A2. We are trying to find A1. It's the same question. It's the same thing here. So you will say F1 is equal to what? It is equal to A1 multiplied by F2 divided by A2. Now guys, do I have A1? No. Do I have F2? Yes. Do I have A2? No, I don't have area, the second area. So we are going to find it using the radius. I told you sometimes in the question you're going to be given the radius, you should find the area, then you will have to put it in the equation. So area 1, or the first area, is equal to pi r squared, the first area, careful. Then area 1 is equal to 3.14 times R1 is equal to, it's equal to 5 times 10 to the power of minus 2. This is meter squared. And this is equal to what? This is equal to 7.85 times 10 to the power of minus 3 meter squared. Same thing for area 2. You'll say pi r, the second r squared. Then you'll say area 2 is equal to 3.14 times R2 is equal to 15 times 10 to the power of minus 2. Then, is it minus 2? Yes, minus 2. All of it squared. Then you have A2, which is equal to what? Which is equal to 7.07 times 10 to the power of minus 2 meter squared. This is area. And this is the second area, and this is the first area. Take them and put them in the equation. So you have F1, which is equal to area 1 is equal to what? Is equal to 7.85 times 10 to the power of minus 3 multiplied by F2. F2 is equal to what? Is equal to 1.33 times 10 to the power of 4. All of this divided by the second area, which is equal to 7.07 times 10 to the power of minus 2. Calculate this and you will get 1,476 Newton, or you can say 1.48 times 10 to the power of 3 Newton, approximately. B, guys, it says what? B, it says what pressure produce this force? And it says neglect the weight of the pistons. So you're going to say what? You're going to say pressure is equal to A1 divided by, F1 divided by A1, okay? Now you have what? You have 1.48 times 10 to the power of 3. Divide this by what? By area 1, which is equal to what? Which is equal to 7.85. 7.85 times 10 to the power of minus 3. You get what? You get 1.88 times 10 to the power of 5 Pascal. Okay? Just for your information, you can write this as what? Remember, this was 1 atmospheric pressure. 1 atmosphere, the pressure of the atmosphere. Then you can say 1.88 atm. This is the compared to the pressure of the atmosphere. You have the second question. It says a 1.5 wide by 2.5 meter long waterbed weighs 1025 Newton. Okay, find the pressure that the water bed exerts on the floor. Assume that the entire lower surface of the bed makes contact with the floor. Okay. Now you have width W, which is equal to 1.5 meter. You have length, which is equal to 2.5 meter, and you have the force. It's Newton. Okay, even if you don't know if it's force, you know that it has the unit of Newton, so it's force, which is equal to 1025 Newton. It says what? It says find pressure. So P is equal to what? So pressure is equal to force divided by area. Now, do I have the force, guys? Yes, I have the force. Do I have area? No. You can just say force divided. Area is equal to what, guys? It's equal to width multiplied by length. So you will say width multiplied by length. Then this is what? F divided by, 1250 Newton divided by what? Divided by 1.5 times 2.5, and you will get 273.3 Pascal. Okay, this is what? This is the pressure. And you have question 3. Question 3, you have a person rides up to a mountaintop, but the person's ear fails to pop. That is the pressure of, if you have felt this when you are driving or when you are riding a car, you feel that sometimes your ears are not popping, okay? So this is due to the difference of the pressure inside and outside in the car and in your ears. Now, the pressure of the inner ear doesn't equalize with the outside atmosphere. The radius of each eardrum is, so radius is equal to what? Radius of the eardrum is equal to 0.4 times 10 to the power of minus 2 meter. The pressure of the atmosphere drops from 1.010 times 10 to the power of 5 Pascal at the bottom of the lift to 0.999 times 10 to the power of 5 Pascal at the top. So you have P1, pressure 1, which is equal to 1.01 times 10 to the power of 5 Pascal. And you have P2, which is equal to 0.998 times 10 to the power of 5 Pascal. Okay. A, it says, what is the pressure on the ear, on the inner ear at the top of the mountain? Okay. So it needs pressure. You just have to find what? You just have to find the net pressure. Okay. You have net pressure, pressure net, which is equal to what? Which is equal to P1 subtracted by P2. Okay, then you have what? You have 1.01 times 10 to the power of 5 minus 0.998 times 10 to the power of 5. Then you have what? You have 1.2 times 10 to the power of 3. Okay, Pascal. This is what? This is the net force on the ear, on the inner ear. B, it says what? B, it says, what is the magnitude of the net force on each eardrum? Okay, so it needs what? It needs the force. Okay, guys? Now look. You have pressure, which is equal to what? Which is equal to F divided by area. Okay, which is force divided by area. Now, do you have pressure? Yes, I have pressure, which is here. I found pressure here. Do I have area? No, I don't have area, but I can find it using the radius. Okay, now if you rearrange this equation, you will get F, which is equal to pressure multiplied by area. Now let's find area. Area is equal to what? Is it equal to pi r squared? Okay, then you have what? Let's 3.14 times, this is the radius, 0.4 times 10 to the power of minus 2, all of it squared. let's multiply this and let's see what do we get. 0.4 times 10 to the power of minus 2, all of it squared. You get you get area is equal to 5.024 times 10 to the power of minus 5 meter squared. Now this is what, guys, this is the area of the eardrum, okay? Because you had radius in the first place. I told you whenever you have radius, try to find area with it. Now F will be what? F will be 1.2 times 10 to the power of 3 multiplied by area, which is equal to 5.024 times 10 to the power of minus 5. Now the final result will be what? The final result, let's multiply this. 1.2 times 10 to the power of 3. You have 0.0602 Newton.